Hello, everyone. My name is Johannes Beetz. I'm an industry process consultant in the industrial equipment team in ECAL with the main topics of DELMIA applications and here especially DELMIA machining. Today I will demonstrate you what we showed at the trade fair EMO Hannover this year about automation in NC programming with DELMIA machining. I will start with a short overview what you will see in the next few minutes. On the right side, you see the agenda. Here we start with the accelerated setup creation. That means how fast the programmers come from a template to an entire created setup and can start NC programming or start the value creation process more faster. The second point is the manual reuse of machining cell know-how. The second point is how we work or how fast we could machine holes with DELMIA machining. And the last step today will be an automated programming with user-defined features. Okay. On the left side, you see the portfolio of DELMIA machining. What you can use for this presentation or for this demo, which roles I needed. You can use the NC shop floor programmer up to the NC mill turn machine programmer. That's all the program roles, okay, to create the NC code and or the NC process. And for sure, to create the machining cell know-how, you need the NC knowledge manager. For the first step, the accelerated setup creation, you need as well the templates and rules designer. And now we will go into the platform. I need to close the presentation. And here we are. You see, we have here our part. And here our CAM template. You can store it in libraries or in bookmarks. How looks like this template? You see here a lot of entries, but the important topic is here, the components. We have our CAM template. That's the actual manufacturing cell. We have a machine accessories, a manufacturing product. We have some tools inside. And here we can set some parameters. For example, for the rough stock, the height, the length, and so on. We can give a clamping configuration and the orientation of our jaws. Here you see in the middle which components will be processed, so will be duplicated. And for here, for example, the machine will be not changed. Okay. So how we could create this? We have here our CAM template. We say initiate, select the CAM template, and now it will generate us a new manufacturing cell. And then we can insert the parameters. Why is this functionality so important? So you could use your value creation process because setting up manufacturing cells with all resources is not really a value creation process. The value creation process starts at the programming top. The second one is you have a consistent use of resources, and your administrator has a better handling of all resources because he definitely knows which resources will be used on which working place. So the next step is I will set up here the part, say OK. And now we see here our manufacturing cell. We open the parameters, and now for sure I know which dimension has our rough stock. And the next step is we want to have a configuration of our clamping configuration. And for sure, that's only now an example. You can choose more chucks and more jaws and so on. For example, I take this one too small. Now it's loading all resources, and you see the part and the rough stock is already placed. Then we set to large. We could rename it, for example, here, demo 02, close it, say OK. And now our entire manufacturing cell is ready to start for programming. What do you see here? We have the part is placed, the resources are placed, the machine is already there, and we have some tools predefined, for example, in this machine or on this working place. Now we go to the activity process view, and now the next step is to design the input and the output part. For this one, I can choose here the part, and this is, if you want, you can automate this step as well. Choose here a material and then say OK. Now you see our roughing operation that is already inserted in this template is already, we could start to program it. But before we want to open the machine instruction to set up our chuck, set it here to 1.5, say OK, open the roughing operation. Everything is defined from the part operation and the predefined from the templates. And then we say display the toolpath. And this is the way how fast it is to come from an engineering template with a manufacturing cell and predefined resources to an entire or to a first entire toolpath. Okay. And now we want to go on with the programming. What's the next step? We have the roughing operation is already created, and now we want to machine, for example, this pocket. We don't have a feature recognition for that for now, okay, in our template, but we could use, and this is what I will demonstrate you today, how flexible the machining cell know-how is, that we have a guided geometry transfer, okay? How does the machining cell know-how looks like? It's, for example, this. We have here a contour, and now we want to apply this contour to our part. Oh, sorry. For that, we go to the automation tab, say similar programming. It's already opened in another tab, so we see it's in session. We could choose it. Select an manufacturing program, say manual, and now we are in the guided transfer to set up all geometries. So I go here to guide. I will take this a little bit more here. Guide up. And now you see that we don't need to set up a strategy, but we have defined one geometry and all macros are defined as well. We go to the next step, say guide here. You see here the entire program that we are now transfer on this part. Say OK. Go to the bottom. Geometry is defined. Go to the next one. We have already the possibility to create the informations for macros. say here the limit line. Limit line could be a surface as well. Go to the next operation, to our last one, and this is really important at this step. The 3DX remembers about your chosen geometry before. So if you have a longer program, you need to select every geometry only once. Then we go back, say validate and exit. Say here, compute toolpath. And you see now the toolpath is correctly transferred to our specific pocket here on the side. This was the second part of this demonstration, and now we want to go on with the fast hole machining topic, okay? At first, we need to have a look which machinal actual features we have already in our part. For that, we could use the hole feature recognition. Say okay, and now you see which information comes from CATIA into DELMIA. And here, for example, we have a countersunk hole, counterbored holes. We have toleranced holes, 3 ones, one with a greater diameter, 2 small ones. And here as well, we get the thread diameter, the thread depth, the thread pitch. So this gives us the possibility with the machining cell know-how now to compute the entire machining program in one click, okay? How does this work? This is the template, how it looks like. It has for every feature that we want to have in our template and part operation, and then it could have several manufacturing programs with different checks. For example, different material, you have different materials, different sequences then, and so on. How does it looks like? We have here a check, for example, for the diameter and the depth. Then we could as well import here or create here some formulas with rules. We have here materials, and DELMIA Machining will automatically create the patterns. So this is something special because we don't need to reassemble them at the end or create the patterns at the beginning. It will be the system will do it automatically. So we can go out with close. The second point is at first the automatic tool query. So we have here the inner diameter of this thread we get directly from this machinal actual feature in our template. And this looks like with the whole search as the same I showed you before. And for sure you can create or insert some customer specific formulas and so on. The second point is we get here the inner diameter directly from the MAF. You will see it here for the inner diameter, for the depth, and so on. And especially you can customize your user interface. For example, here we have locked the drilling mode. We have created our own customer tabs. That means in every machining cell, now what I showed you today, you can create your own user interface. If you go to customize mode, you see we can say here unlock, lock, for example. We have here chosen a custom tab for these 2 parameters. And you see here we can insert some user parameters for customer specific cycles, standard cycles, or anything else what you need for your process, for your output. You have the different types, booleans, reals. You can insert here formulas, for example, and you can choose in which tab you want it to have. We can say preview, go here and see the predefined user parameters. Next step is we go to our template, and we have the possibility with create commands from machining cell now to insert it directly in your user interface. It's not specially here in this tab, but you can create it or you can insert it every tab. We started here directly from the user interface. That means the NC programmer does not search for it in the manufacturer in the database. Okay, here are all our features. We say recognize. Now we get a small color coding. Here the two threads. Here the two small tolerance holds. You can choose it. You can deselect it if you want. The greater diameter tolerance hole, counterboard, and countersunk holes. Next step is we say apply. Now it will be copied directly, or not copy, transfer automatically the operations with all checks and all informations from the template to this part or to this holds. That means you don't need to open a machining operation at the end. It will be done completely automatically. Now you see all holes are defined. And now we want to check if everything is working correct. For example, at first, we say here, we have a tolerance hold H7, what I showed you at the beginning, and we compute it here directly in the mid tolerance. Then we go to the tapping operation. You will see here the correct inner diameter, the correct depth, and here as well our customized user interface with the correct user parameters. Okay, this was the second part of the the second part of the of this presentation, and now we want to go on with the user defined features. Okay, for that I go to another manufacturing cell. We can hide the machine and hide the stock. And now we see here our part with a lot of different features, okay? And the features are in combination. For example, here we have 4 side pockets, 3 side pockets in a greater pocket. We have ribs with radius, and so on. And now we want to compute the entire machining program with one click from a machining cell know-how. With that, I want to show it how easy it looks like. We have here this easy geometries, but the combination of that will be create us the entire program. It works with the checks the same as I showed before in the machining cell know-how. And for that, I want to open this pocketing, for example. We can have here create some measure features, and this measure features we can directly insert in the tool queries and in all geometry parameters in the machining operation. It looks like here, for example, I have measured this radius. I say multiply it with 2 and say then -2 millimeters. For sure, it's now an easy example. You can create your own examples here, but you have directly access to the geometry. I go to close. And the same, what I showed before with the user interface. For example, we locked here the toolpath style. If I go to customize, you see unlock, lock, and the same we can do with the hide and show and merge the sub-tabs if you want. Say okay, then we go back and now we want to apply it. We want to see the machine. Go to the process view, and here we see we have at first we have created maybe from a template a facing operation. This could be inserted in this template as well. So we have already have it here in our user interface. Choose a manufacturing program, and here you see our user-defined features. Say recognize. I did. And here we see all the found features, the cooling ribs with, without and radius, with radius. You can deselect if you want. We see here the greater pocket. It's this one, it's in red, and so on. The next step is that we apply the entire program. And now you will see we compute the toolpath. We search for the tools. And the NC programmer does not need to open one of the machining operations at the end. Here you will see we have created round about 60 machining operations. The next step is we say compute toolpath. Toolpath is computed. Don't worry here, this warning message is only about that we have, it's about the macros that it will have changed the values automatically. And the next step is we have here sometimes the same tool in different operations, okay, from different features. So we want to merge them, that we reduce the tool changes. For that, I go to programming, use the auto sequence, have here inserted some rules. The program is defined, say okay, and now all tools will be checked, and we have a reorder of our machining operations. And now we can say compute toolpath. Or simulate, not compute, it's already computed. Now it will be checked if everything is fine, everything is computed. And we can start the simulation. I will do it a little bit faster. Here you see the toolpath. You can hide and show it. The small pockets inside the bigger pocket. We have not only 2.5 axis operations for sure. We have a tracheoid milling operations for the ribs. And the sweeping operations for the radius. Okay, with that, I will come to the end of my demonstration and close with a short with a short overview of the key takeaways. At first, we have seen the accelerated setup creation to boost your value creation process. That means to start NC programming. The second step was the reuse, so how flexible you are to use or share your best practices in the company. The third point was the fast hole machining, which informations we get from CATIA or SolidWorks. You have a standardized and traceable tool usage. It will be every time then the same. And you have a high scalability because you can apply this machining cell know-hows every time on different parts if you have created once. And at the end, with the user-defined features, and the NC programmer is able to compute or to create a machining program in one click if he has set up a machining cell know-how, maybe for a product group as best, and increase his productivity and reduce errors. Thank you very much. And now I'm at the end. And if you have questions, please feel free.
So if you have any questions, please don't hesitate to ask. We have one question often, Johannes, which is, which roles did you use to do this workflow?
For which of them?
I guess we can take the example of NTX.
I mentioned it at the beginning. So you are able to use all. So for the creation, you need one of the programming roles, okay? Beginning from the shop floor programmer and to the NC mill-turn machine programmer. And you use the NC knowledge manager. But for the NC knowledge manager, you need one to create the machining cell know-how. For applying the machining cell know-how, you only need one of the NC programming roles.
Yeah. Okay. Yeah, we have a question from CB Zakaria. Would you like to? I can give you the possibility to speak. So I think you'll be able to speak, Mr. CB. You have to unmute yourself.
Thank you, sir. Can you hear me now?
Yeah.
Yes.
Quick question. Now, with the migration, is this the license packages like as we see NSR, NPM, NTP, NMD, NTX, and NTA under the NC machining to be used for the machining? This is how it's going to be packaged?
Yeah, exactly.
Okay. So I see that NC Prismatic and Milton are together, are branded together.
Yes, that's from one side you have possibilities for 2.5 milling, and you can do turning operations with this role.
Okay.
The functionality for sure is a little bit, the NC shop floor programmer is a little bit out of that, but the NC prismatic machine programmer, you have from left to right more functionality. For example, here you have all the multi-axis machining operations inside, and here then you have the multi-axis machining for turning and for milling.
That would be the NTA license.
Yes.
Okay. Okay, understood. So,
if you want to have more information, I guess a good source of this, the fabrication community. Every role is described in the wiki, or you send us a mail and then we can send you this information.
Okay. Now, quick question. Do we have any added capability like 90-degree head tool changers in the tool management or anything like that that's not present in the current V5 platform?
I'm not sure if I understand it correct. Could you please explain it again?
With the new migration to the system, is there any added functionality like the angle heads like on the tool, the different types of tool that we can select is end mill, drills, boring bar, reamer, and yada yada. And does an angle head or a 90-degree head
Yeah, yeah.
in that tool?
Yeah, it is supported in with our for example, a mill turn machine may have that. Something similar or a complex machine with angle heads is something we support in DELMIA Machining on 3D Experience. We've done it for a customer.
Okay, that's something that's not coming right out of the package. That's something else. Is that what I'm hearing?
No, it's right out of the package. It's nothing.
It's right out of the package.
Yeah, it's not an additional role or anything that that you see that you need specifically for angle heads. No.
So another question would be those who have production versions of V5, it would be a transfer to DELMIA or is a brand new license purchase?
We are working on a transfer on a license migration path. And if you want, you can reach out to me, and I will put you in touch with the right people on our sales side for that.
Okay, understood. Thank you, sir.
We just have one more question. I don't think we'll be able to answer more here. The last question, Johannes, we have is, does the part have to be designed with user-defined features in order to be recognized?
No, that's I can go back.
Morning, we start.
Yeah, go ahead, Johannes.
No, so totally not. So it's not, they don't need to use, for example, a pocket in CATIA or something like that. The feature recognition of the user-defined features will automatically find them if they have, for example, same points, and you need something to refine it, but is don't has a direct link to dimensions or something like that.
Okay. I think that's all we have time for at the moment, Johannes. So I think we can end it here. And as Johannes said, if you have any questions, don't hesitate to reach out to us offline. Okay. Thank you, everyone.
Thank you.